আপু। ఇది మరి ఇంతసేపు టైం వేస్ట్ చేసి ఫోర్త్ ఆన్సర్ ఫిఫ్త్ ఆన్సర్ రాసేసి కాగితం దాన్ని వదిలేసేది అప్పు ఇది రాయి నువ్వు ఆన్సర్ నాకు ఆన్సర్ నా క్వశ్చన్ పెట్టిన దగ్గర దానికి సంబంధం లేదు రైట్ నిన్ను గోల్కొచ్చి చంపుతాను
She's really cool, man. They're totally flat. Yeah.
Good evening, all. So, we're going to discuss about the enzyme inhibitions. Inhibitors here. So generally, what we mean by enzyme inhibition, right? So enzyme inhibition means generally the drug molecule. Okay, so the drug molecule, so which will be occupies the enzyme active site, right? It occupies the enzyme active site, and it prevents to, right? It prevents to occupy the natural neurotransmitter in that particular enzyme active site, right? So that process is called the enzyme inhibition. So we know that every enzyme is having its own cavity, right? So that cavity is called cavity in the sense that is a empty space here. That cavity is called the, right? So active site. Yeah. So right. So just for example here, just this is the enzyme here, right? So this is enzyme. So where this enzyme is having a empty space or the active site. Okay. So this site we facilitates for the of natural neurotransmitter or molecule, right? So both will be natural neurotransmitter. It may be occupies so generally this natural neurotransmitter and the drug molecule. So both will be compete to each other to occupy these active site of the enzyme, right? But generally the drug molecule which is artificially prepared and it will be the more efficient than the natural neurotransmitter. So obviously the drug molecule will be occupies the active site and it inhibits the right? It inhibits the means entering or the in occupying the national neurotransmitter. In this way, it will be blocks that, right? It blocks the action of the national neurotransmitter. Okay. So generally that is called the inhibition. Okay, that is called the inhibition, means where the drug molecule is occupying the enzyme active site and it prevents to occupy the national neurotransmitter, or it blocks the enzyme active site here. Okay, this process is called the enzyme inhibition. Okay, and we know that the enzyme inhibitions are various types. Okay, like reversible inhibition and irreversible inhibition. And in the reversible inhibition, again, three types here: competitive inhibition, companies where enzyme active site, okay, competitive, right? With the inhibition. Inhibition, it is two types here. Basically, it is competitive, okay, reversible here and irreversible. Reversible and reversible again, right? Companies where the active sites and okay, competitive active site. It is a competitive between the national neurotransmitter and the drug molecule. So that is competitive, right? Reversible inhibition and non-competitive. So non-competitive means, so here also both molecule like national neurotransmitter and your drug molecule will be tries to accept. But generally, every some having, okay, some of the enzymes are having its own, right? In addition to this active site, original active site, that is called the allosteric site. Okay. Allosteric site here, right? Allosteric site means the allosteric site is the additional active site here, right? Additional active site. So this drug molecule will be, it won't occupies the active site here. It will be occupies the allosteric site. It will be binds with the allosteric site. Then what will happen here? Due to right binding of the drug molecule, okay, due to binding of the drug molecule to this allosteric site, right? So it brings the changes in the right active site here, right? So some conformational changes will be takes place in the enzyme original active site here. So that active site is not feasible for the occupying the nasal neurotransmitter. Okay, nasal neurotransmitter will not be, right? So it won't occupy this active site due to conformational changes of the active site here. So why the conformational changes is arise is here? Due to occupying the drug molecule in allosteric site here, right? So this allosteric binding brings the changes in the conformational changes in this active site here. So in this way, it is inhibiting to binding of, right, of national neurotransmitter. Okay, so that is right. So non-competitive here. So like that, this is the inhibition. Okay. So here inhibitors, right? Inhibitors means which inhibits a enzyme active site here. Okay, so enzyme inhibitors. So this is very important topic here. So in this enzyme inhibition, we have various types here, right? So here the ACE inhibitors and H plus K plus ATPase enzyme inhibitors. This is also called as proton pump inhibition, right? Proton pump inhibitors. Then carbonic anhydrase inhibitors and glycosidic inhibitors, right? So these are very, very important. ACE inhibitors and H plus K plus ATPase enzyme inhibitors, right? And the another name for this ATPase enzyme inhibitors is a proton pump inhibitors. Okay, proton pump here. This is very, very important. This proton pump is very, very important. Okay, and ACE inhibitors also. These two are very important. Right? So this is important. You can keep any 5 or 4 or 6 stars here and ACE inhibitors. Right? This is important. Then carbonic anhydrase and glucoside. Okay, glycosidase inhibitors here. Right. So we'll see the in detail of these inhibitors. Right. So first we'll see the ACE inhibitors. Right. ACE inhibitors here. So ACE means angiotensin converting enzyme. Right. ACE means the abbreviation of ACE is angiotensin converting enzyme. Yeah, enzyme inhibitors. Right. ACE inhibitors. So generally here the ACE angiotensin converting enzyme, right? So it is an enzyme which converts the angiotensin, right, inactive form to the active form here. Okay, so here the angiotensin, right, angio, right? So angiotensin, it is a chemical substance here, right? Angiotensin is a chemical substance where it is a what is it? It is a polypeptide. Okay, angiotensin is the polypeptide molecule here. It is a polypeptide molecule, and this angiotensin is generally it is 2 types here, right? Angiotensin is 2 types. Angiotensin 1, okay, angiotensin 1 and angiotensin 2. Angiotensin 1 and angiotensin 2. Okay, so here the angiotensin 1, right? So angiotensin 1, it converts into angiotensin 2 in the presence of ACE. Right? So in the presence of ACE, the angiotensin 1 converts into angiotensin 2, right? Here, angiotensin 1, right? The angiotensin 1, it is a right? It is a decapeptide molecule. Okay, polypeptide here. It is decapeptide. And this decapeptide angiotensin undergoes this, right? It undergoes a hydrolysis in the presence of ACE. In the presence of ACE, it undergoes a hydrolysis and it converts into angiotensin 2, where the angiotensin 2 is the octapeptide. Okay, it is a octapeptide here. Octapeptide means octa means 8. There are 8 peptide bonds are there. Okay, so like that. So it is the general and the regular conversion, right? It is the general and it is a regular conversion of this angiotensin compound or the molecule here, right? Angiotensin 1, it converts into angiotensin 2, right? So to convert this angiotensin 1 into angiotensin 2, right, the required enzyme is a ACE, angiotensin converting enzyme is required. Means in this presence, in the presence of angiotensin, right, ACE, angiotensin converting enzyme, this conversion is taking place. Means the decapeptide angiotensin converts into octapeptide conversion. Okay, so this decapeptide or the angiotensin 1, it is a inactive form. Okay, angiotensin 1 or the decapeptide, it is a inactive form here. Inactive form means it won't involve in the reaction. Means generally here the angiotensin chemical. Okay, so it regulates the blood pressure. Actually, the function of this one. Okay, the function of angiotensin is BP. Okay, it regulates the blood pressure here, right? So here the angiotensin 1, where it is a decapeptide, right? It is inactive form here, and it won't regulate the blood pressure here, right? So it undergoes hydrolysis and it gets hydrolyzed and it converts into angiotensin 2. It is a octapeptide, and this angiotensin 2 is a active form, right? It is an active form and it regulates your blood pressure. It regulates your blood pressure, BP. Okay. So, okay. So this is the continuous process and regular process which takes place, right? In the hot muscles here, smooth muscles. Okay. So, but due to more activation, right? So due to more activation of this ACE, right? Due to more activation or the over excitement of the ACE, right? So the more conversion of angiotensin 1 into angiotensin 2 will be takes place. Okay, there is a angiotensin 1 in the presence of ACE, it converts into angiotensin 2, isn't it? So due to overactivation or the more excitement of the ACE, right? Where the uncontrolled conversion of this one, right? Where the more conversion of ACE2 will be takes place. Angiotensin 2 will be takes place. Then what will happen here? If more angiotensin 2 is formed, right? If more angiotensin 2 is formed from angiotensin 1, then what will happen here? Where it increases the blood pressure, right? So it increases the blood pressure here, right? So if the blood pressure is increases, then what will happen here? So it leads to the development of the high BP, isn't it? It leads to the development of the high BP. We call that is a high blood pressure, right? So hypertension, we call that is the hypertension here. Okay. So this hypertension is arised due to the overactivation of the ACE. So how this ACE gets overactivated? Why this ACE gets more excited here? Due to our lifestyle here. Okay, due to our lifestyle. Okay, because due to our lifestyle, where this it impacts on the ACE enzyme, angiotensin converting enzyme here, right? So due to
కాబట్టి
these factors.
ఇప్పుడు మీరు కింది స్థాయిలో ఉన్నారు కాబట్టి ఇప్పుడు హార్డ్ వర్క్ చేసి ఆ పై స్థాయి కాకిలాగా పై స్థాయి.
Hello.
ఒక
Okay, so yeah, due to our lifestyle, right? So this the more conversion of here the angiotensin 1 here, right? You see. So due to the lifestyle here, okay, due to our the factors, due to some factors here, right? Due to some factors, this ACE and it gets more excited or more activated here. What are the factors causing for the over excitement or the over activation of this ACE here? So we know that the factors, right? So many factors are there, like okay, the hurriness here, right? So simple in the simple language, already I told you there is a hurry, okay, and worry here, and the curry, right? So these are the factors. Means hurriness means the excitement, right? Worry. This is the depression, and the curry means the food habits here, okay, the food habits. So all these are the factors which cause the over excitement of your angiotensin converting enzyme. So due to these factors, okay, due to these factors, this gets over activated, right? Then it increases the blood pressure, right? It increases the blood pressure here, and it develops a high BP, right? So then in that case, so how to control that high blood pressure here, right? So there are two methods are there. One is, okay, one is you can inhibit the ACE by enzyme inhibitor. Okay, you can inhibit the ACE by enzyme inhibitors, means the drugs. Enzyme inhibitor means it is the drugs only. Okay, drugs. So like here the captopril and the enalapril. Captopril and enalapril drugs. If you take these drugs here, right? So these drugs will be, right, occupies instead of ACE, right? Instead of ACE here, right? So they will be operates this mechanism, right? So they will bind with the angiotensin converting enzyme. These enalapril and captopril, they will binds with the ACE and they make this ACE inactive. They make this ACE enzyme, angiotensin converting enzyme, inactive. Then what will happen here? So no conversion. So this route, this pathway will be blocked here, right? Because there is no ACE here, right? ACE is binded with the captopril and enalapril here, right? These drugs are binding the ACE. So here the conversion of this angiotensin 1 to angiotensin 2 will be stops there. Then what will happen here? The blood pressure will be comes in the control. Okay. So here is the captopril. Okay, this is the captopril where this is the amino acid here, right? So the where this is the amino, it is having the amino acid, right? Peptide bond. You can see the peptide bond. And this is a peptide here. Peptide bond, right? So this is the captopril structure where the anti-hypertensive drug captopril, it is anti-hypertensive drug. And if you see the stereochemistry of this one, it is S and S form, right? There are two means there are two stereogenic centers are the chiral center, right? Two chiral centers, right? Two chiral centers. So this is one here. This is another. There are two chiral centers, right? So if you see the stereochemistry of this chiral center, it is S configuration. Here also S configuration, right? So this is the SS captopril. SS captopril is the active form, and the R, right? R comma R captopril is R comma R, captopril, it is inactive form. It is inactive. And S and S is the active form. Right? Now the synthesis of captopril. So how the captopril is synthesized? So very simple method. Right? So the by taking this thioestic acid as the starting material here. Right? So thio group is there. SH means the thioestic acid is, it is treated with the acrylic acid. Okay, methyl acrylic acid, where the this double bond, right? So it is called the methyl acrylic acid here. Okay, and it is going and it is giving the right racemic mixture, plus and minus racemic mixture. So doing English, right? The resolution is the suppression. Resolution method is the suppression method. And we need the isomer. You can reject the R isomer. You treat with this thionyl chloride here, right? So we treat thionyl chloride. So this acid group, right? This carboxylic acid group is converting into acid chloride here. Carboxylic acid group converts into acid chloride. Then yeah, then you treat with the proline, right? Here is a proline here. This is the proline amino acid, right? So this is proline. So you treat with the proline here. Then what happens here? Then this proline is going to attach with this particular the intermediate compound, right? Now this intermediate right? You treat with the base. This is and very simple here, right? So what you do? Simple, you take thioestic acid and you treat with the methyl acrylic acid here. Then you will get the racemic mixture. And by doing the resolution method, you can separate the S isomer. And to this S isomer, you treat with the thionyl chloride. And this thionyl chloride, right? So it converts this acid, carboxylic acid into acid chloride here. Okay. And further, you treat with your proline. Then by removal of this hydrogen from this proline and chlorine from this acid chloride, it is going to remove as a HCl, and it is going to attach. The proline is going to attach with your this particular acid chloride derivative, right? You will get this acid chloride derivative here. And now by treating with this sodium methoxide, okay, sodium methoxide, right? So by cleavage of this bond here, right? So by cleavage of this bond, finally it is giving your SS captopril. So this is right the synthesis and the structure of the captopril here, and synthesis of enalapril. So this is also same like your that particular captopril, but here the starting materials are different. Where the oxalate, right? The diethyl oxalate, when it is chloride, right? Slowly captopril and enalapril drugs. Compare enalapril to so less effective than this captopril. The enzyme inhibitors are proton pump here. H plus K plus ATPase enzyme inhibitors. Here, acid secretion, against gases. And here the right. So the hydrochloric acid will be produced in your stomach, right? So by some glands, okay, acid glands are there. This hydrochloric acid will be produced in the stomach, and it is required actually, okay, right? The HCl is required for the digestion of the food, and generally it is a defensive process, right? Defensive process. The production of the HCl in the body or in the digestive system is a defensive process, because the HCl will be kills the bacteria. Okay, it kills the bacteria and it helps in the digestion of the food here. That's why the HCl plays very important role in the what is that, in the stomach here for the digestion process here, right? It will be kills the bacteria and prevents from attacking of the bacteria. Okay, but when this acid production is excess, when this acid production is excess, then it will be harmful to your body, right? So in the limited or the controlled amount of HCl is required our body here. But when it is more, right, the production is excess, then it will be leads to some diseases here. Okay, right. So then how to control this excess acid production? Okay, how to control this excess acid production? So generally we have three methods here, right? We have three methods to control the excess acid production or to control the acid secretion here, right? So the first, neutrally released acid by antacid. Okay, so neutral acid, because the excess acid is released, and that excess acid release ulcers, right? So okay, so excess acid, right? HCl production, right? It leads to the ulcer. Three three methods are available. One is, okay, so you can neutralize this acid by antacid. Okay, so antacid means which acts against the acid. Bases here, right? Antacid means the base. Here the acid is there, right? So if you treat with the antacid, right? Right. So if you treat with the antacid, that acid will be neutralized, right? And the acid production will be comes in the control here, right? That is one method. And the second method is by blocking the H2 receptor by drug such as ranitidine. So Right? So it produces so block this no production of the HCl. If then so if the H2 histamine receptor, then okay, yeah, right. Here is a H2 histamine receptor, right? So if you block this active site with the ranitidine, right? Rantac, generally we call the rantac, right? So ranitidine. So you can take this ranitidine. It is anti, right? Ulcer drug here. Okay. So ranitidine. So this ranitidine will be blocks this histamine receptor active site. Then what will happen here? If it blocks this histamine receptor active site here, so it prevents to occupying the natural neurotransmitter, right? So it won't comes here because already the ranitidine is occupying this active site. So if the natural neurotransmitter is not occupying this active site, then this histamine receptor will not be gets activated. So it won't produce a HCl. It won't produce the HCl. So production of the HCl, excess production of the HCl will be prevented here. That is another mechanism to control the excess production of the acid. And the third mechanism is by inhibiting the H plus K plus ATPase enzyme. Okay. So H plus K plus ATPase enzyme here, right? So here is a, okay. So this is H2 histamine receptor here, right? Here ATPase enzyme, H plus K plus, right? So this ATPase enzyme is occupying this active site. When this H plus K plus ATPase enzyme is occupying this active site, this H2 histamine receptor getting more excited, right? This H2 histamine receptor, it is activated here. Okay. So by activation of this H2 histamine receptor, it is producing it is secreting the HCl acid, right? So it leads to production of this HCl acid here, right? So here we have three methods here. Okay. So we won't means we won't affect this H2 histamine receptor or the enzyme here. So after production of HCl, you can neutralize with the antacid. You can neutralize this excess acid with an antacid. That is one method. Or you can block this active site with the ranitidine. Okay, you can block this H2 histamine receptor active site with the ranitidine. Then what happens here? When the ranitidine occupying this, okay, occupying this particular enzyme active site. So the H plus K plus ATPase enzyme will not be right insert this active site here, because already that active site is filled with the occupied by your ranitidine drug, right? So in this way you can control this HCl production. That is second mechanism. And the third mechanism is, so we will target this ATPase enzyme, right? So you can block or you can bind this ATPase enzyme with the omeprazole drug here, right? You can inhibit the ATPase enzyme with the omeprazole drug. Okay. So these are the three mechanisms established to control the excess production of the HCl. Okay. Right. So now the synthesis of will be taken. Listen, here the acetic anhydride is a, this is acetic anhydride. So one of this group is CH3CO, right? This group is attached on this amino group here, right? So it becomes N-acylated. Then upon doing the hydrolysis, okay, upon doing the hydrolysis, where this again we are getting this nitration, right? Upon doing the nitration, so where the meta nitration, right? The meta nitro substitution will be takes place here, right? Meta nitro substitution is takes place, and further you do the reduction with the ranitidine nickel. You do the reduction with the ranitidine nickel. Then NO2 group converts into NH2 here, right? NO2 converts into NH2 because the addition of this hydrogen is the reduction, right? So upon reduction with this right? So upon reduction, so where you will get this nitro group into amino group here. Now the diamino ether. Further, you treat with the urea. Okay, you treat with this urea here, right? This is urea. When you treat with this urea, right? So where the okay, so this amino group, right? So this urea, it undergoes a condensation here, right? So where the peptide bond is formation, and then it further it undergoes a cyclization here, right? So upon cyclization, you will get this particular derivative here, intermediate derivative. Then upon treating with POCl3, phosphoryl chloride, right? So where this ketone converts into chlorine derivative here, right? Then you can react with this pyridine derivative, right? So when you treat with the pyridine derivative here, the substituted pyridine, so this pyridine pyridine derivative is going to couple with this particular compound here, right? It coupled with this particular compound, and then upon treating with the hydrogen peroxide, or the oxidation reaction with the hydrogen peroxide, right? So this sulfur ether, right? The sulfur ether is gets oxidized, and you will get the sulfonyl derivative, and this is your omeprazole drug compound. So generally, like kidney, essentially the blood purification will be takes place here. And carbon dioxide, evaluation of carbon dioxide, and carbon dioxide, right, which is evaluated due to the metabolic process, right? It is converted to CO3, carbonic acid. It converts into carbonic acid. Carbonic acid. Okay, this so it under dissociation, right? This carbonic acid dissociates as a HCO3 minus bicarbonate ion and the H plus ion here, right? This H plus ion and the bicarbonate ion. This will reabsorb, right? The H ion will, right? It will be reabsorbed by your dish, like epithelial cells, right? So epithelial cells. So it will be reabsorbed, and the exchange of, right, exchange express the species absorbed inside the CNAPS will be released outside here. It will be exchanged, right? In a place here. So right outside. So this is a general process here. And this comes inside here, and sodium goes outside. And which is the minus bicarbonate ion and sodium bicarbonate. Exit, uh, right? Here, the exchange of this H plus with the sodium will be takes place, and it will be combined with the bicarbonate ion, and it is converting as a sodium bicarbonate. It is excreted by the urine here. Okay, so this is a general process here, right? But due to the failure of function of the carbonic anhydrase, right? So here the CO2 and the H2O converts into carbonic acid in the presence of carbonic anhydrase enzyme, right? So this is an important enzyme which converts the carbonic acid. After formation of this carbonic acid gets ionized, right? It undergoes the ionization, and it releases a H plus ion inside the inside this particular tubular, what is it, fractional tubular epithelial cell here, right? Means in the kidneys, right? So in the nephron, H plus will be released in the nephron here, and simultaneously the Na plus means the sodium, right? Simultaneously the sodium will be, right? So it will be removed from the tubular fluid, right? So this is the continuous process here. But if, right, so if this carbonic anhydrase is failing its function, if it is failing its function, then the more conversion of carbonic acid will be takes place, right? The more formation of the carbonic acid will be takes place. If more carbonic acid formation is takes place, then what will happen here? More release of H plus ion, right? It leads to more release of H plus ion here. Then if the more concentration of H plus ion is increases, then what will happen here? The more excretion of sodium ions will be takes place, right? If the more accumulation of H plus ion is takes place, then the more removal of Na plus ion will be takes place here. Then what? Then your body will be, right, lack of the sodium ions, right? The shortage of the sodium ions here, and the H plus ion concentration becomes more. So the accumulation of water, right? The accumulation of water will be takes place. So the accumulation of water is called the edema, right? It leads to the edema disease. Edema means, what is edema here? More accumulation of water in the body, right? Body tissues. More accumulation of water in the body tissues is called the edema. So why this edema, right? Edema stage is takes place here. Edema condition is takes place due to more formation of the carbonic acid. Due to more formation of the carbonic acid, it leads to release of more release of the H plus ion here, right? When the more H plus ion is released, then the more excretion of the sodium ion will be takes place. So your body will be lack of sodium ions and excess of H plus ions, right? So the more sodium ions will be excreted by the urine system, right? Means, so this condition means the more excretion of the sodium ions by urine system is called the, right, what is it, diuresis, right? Diuresis. So means the more urine, right, the more sodium is released, excreted through urine system, right, where the increase excretion of the sodium chloride here, right, because the sodium is more removed from the urine system, right? So your body will be faces the shortage of the sodium ions here. Means that sodium nutrients are less, so it leads to some deficiency, right? The deficiency or the disease that is called the diuresis here. Okay, diuresis. So in this case, diuresis, uh, uh, diuretics, So of the and to this uh, to through immune system. Some other disorder are and one of the good example for this enzyme inhibitor, right? Yeah. Taking this particular okay. So this particular thiazole is gets acylated and further it is treating with chlorine. Okay, chlorine molecule. This as here, and you will get this final treating with the so this engine inhibition. Enzyme inhibition of the with the drug here, right? So I'm stopping here. So we'll see in the next class.